All right, good morning, everybody. This is not ideal. I wish I was in the classroom with you, but I'm not. I'm here at home. I'm doing fine, though. I'm feeling much better, but still testing positive, so I won't be until Monday. First off, the statistics that we're going to do is not going to be on the quiz, so don't worry about that. Just focus for the quiz on Monday on what are on the objectives on your packet. For the statistics, hopefully you had some time on Tuesday to go through the descriptive statistics notes that are right down here in your module 1.61. If you haven't done those yet, I'm going to say pause this video, go do those notes, and then come back when you're done. I'm going to be going over the variation analysis lab and kind of showing you my example and how to do the statistics using Excel. So this is what we're going to be doing, 1.63. You have today and you have tomorrow, Friday, to finish this up. It's due by 3 p.m. on Friday. I'm going to have posted on Canvas a link for you to see who your partner is. I encourage you to work with this person. I think it's easier to do this stuff with someone. Collaboration's part of IB. But at the very least, you can have somebody that you can check your answers with. You don't have to work with them, but I encourage it. So, two people are going to be given a trait. When you click on here, this will show you the directions. You're going to get this 11 by 17 page, hopefully at the front of the lab or at the front of the classroom. Do this in pencil first. You're only going to get one for the moment. As we're going down through these, you'll see that, again, pairs of students are assigned. So there's a link in the Canvas assignment that will take you to a spreadsheet that will tell you which of these species you're doing and what phenotype trait you're doing. Do not just pick one of these to do. You have been assigned one. Another person in the same class as you has also been assigned one. And again, you can work with them or not. It's up to you. On your chart, you'll see at the top the title. You want to fill that in based on these directions. Draw a picture, sketch. Doesn't have to be pretty. Then you can access the class data from this link. It was also on the Canvas link right here. You'll see at the bottom the different species and the different traits. So you'll have to scroll through here to find the one that you have. And then here's your data. It's telling you how many bins there are, the size of the bin. This stuff you're going to use to make the graph in just a minute. I recommend using Microsoft Excel for this. I'm a Google guy all the way, except when it comes to doing statistics on spreadsheets. Excel, I think, is a little bit better. I'm going to, in my demonstration, use Excel, but please, feel free to use Google Sheets if that's what you want to do. When you have your data, you can download it by making a copy of it if you want to use Google Sheets, or you can download it with Microsoft Excel. Okay. This will give you your data. The example I'm going to use is giraffes and their height, and because I don't want to do one that somebody else is going to do. So this is just data that I have made up that I'm going to use as my example in a minute. Going back to here. So you've downloaded your data. Determine your sample size. Very easy to do. You can just either count. Let me go to my Excel spreadsheet. You can either just count the number of rows, or you can also, as it says here, type in equal count and then give it the values that you want. And it will tell you how many rows you have. I have 30. So my sample size is 30. Yours is going to be different. Write in what your sample size is. Tell me why a large sample size is better. Okay, the next step is to make a histogram, which you're going to see. This is what your graph paper here is for. If you look at your data, it will tell you the number of bins that you need to have. Those are essentially, the number of rows here, the number of bars. So the number of bins are your number of bars. The size of the bin, that's essentially going to be what each bin represents for a range. You can see on the histogram here that it's a range between like 4 and 6 here, 6 and 8 here, 8 and 10 here, and they're putting the minimum number of the range on the dash. So if your range was 0.01 and you start at 0, then yours would be 0, 0.01, 0.02, 0.03, 0.04, and anything that falls inside that range would be a bar. The number of organisms that fall within that range would then be your frequency on the y-axis. I can help you with this when I get back if you're having trouble with it. After you make the histogram, make sure you label your axes too. You want to add a distribution curve as best that you can with a pencil, and then you can color over it. All right, then step 5, looking to see if you have any outliers. These are observations that lie at an abnormal distance from other values in a random sample from a population. Don't worry about this interquartile range yet. Let's not get into that. Instead, I think we all know that outliers are just kind of the exceptions to the norm. To figure out what the outliers are, go to the next slide. You have to look up an outlier IRQ calculator. So let's do that. Outlier IRQ calculator on Google. Doesn't matter which one you use, usually. Enter numbers separated by comma, space, or line break. Let's use this one. Okay, so this one's just a number set. So I can take my numbers from my giraffe, not from this. And I can copy and then paste my number set in here. Now you can separate them using a comma or just put them in a column like that. Calculate, showing a couple outliers. We go down a little bit further. There they are again. Don't worry about all this statistic jargon. We're not going to get into that. But in the 11 by 17 page that you have to list any outliers. My outliers would be these 3. Next, skew. Skew is a measure of the asymmetry of the distribution of measurements of a variable relative to its mean. So when we say the data is skewed, that means that it's not entirely symmetrical around the mean. It doesn't look like this. It's skewed one way or the other. It could be positively skewed or negatively skewed. To calculate skew, the easiest way to do it is to do a skew calculator or to just do it on Excel. If you click these links, they will go to Ms. von Bargen's website that has these wonderful explanations about what the statistical test is and how to do it. An online skew calculator. I'm going to show you how to do it in Excel. So here's my giraffe data. And if I wanted to figure out what the skew was, in Excel, you go to Insert Function, and then you can always type in what you're looking for, and it should show you. I want skew, not skew.p, skew. Push OK. Then you want to select all your values that we're calculating the skew for, and then push OK. And you can see that my skew is negative 0.15, essentially. So, what does that mean? Well, when we look here, we can see that if the skewness is between negative 0.5 and plus 0.5, which mine was, it was negative 0.15, then my data is approximately symmetrical. And that's going to be important in helping us figure out what measure of central tendency we're going to use. All right, so they want you to write your skew value in here. Remember that mine was negative 0.15. The fact that mine is negative tells me that it is slightly skewed to the right, but it's so slight that, again, we're considering it not to be skewed. All right, then the step 7, we'll figure out our measure of central tendency. For this, if you go to the next slide, you can open this page and it will take you to a flow chart that you can then figure out, based on your type of data, are you going to use the mode, median, or mean? So first off, if your data is qualitative, you're going to use the mode or median, but our data is not qualitative. Our data is purely numbers, right? So we're not going to use the mean. We're not going to use this side. We're going to use this side here if quantitative. So it's then asking us about our skew. Does the skew follow a normal distribution? Are there outliers? Was my data skewed or not skewed? Well, being negative 0.15, it's not skewed. So I'm going to use the mean. All right, with the majority of skew values less than the absolute value of 1, my data is quantitative, I'm going to use the mean. So that's why we calculate skew a lot of times, is to figure out which is the best measure of central tendency. Okay, so going back to here, they want us to calculate all 3 just to see. Round your answer to the same number of digits as the initial measurements. Easiest way to do that, you can do it in Excel. Same way, insert function, mode, push OK, select all your numbers. My mode is 4.89. For median, search for median. Select all your numbers. 4.89 is my median. And then for mean, which is what I really want, you can do, actually it would be average here, I believe, in Excel. 4.89. So they're all the same for mine. Could be quite different for you, depending on what type of data you have. I'm going to round it to the hundredths place because that's what my data was in, was the hundredths place already. Your data, it looks like, was also in the hundredths place, so that's what I would round it to. All right. Indicate the central tendencies on the graph. So mine was all at the same spot because my data was very symmetrical, but use this example here to kind of help you out with indicating on your graph where the mean, mode, and median are. All right, now we are down to measures of spread. We're almost done. This is going to summarize how spread out my data is. So we can open this page here to learn how to determine which calculation is most appropriate. Is the variable you are measuring qualitative or quantitative? Quantitative. Does the data follow a normal distribution? Are there outliers? Our data was not skewed. I used the mean, and so therefore my measure of central tendency is going to be the standard deviation. My measure of spread will be the standard deviation, since my measure of central tendency was the mean. It also tells you here in this table, mean with 5 or more trials per level, which is what we had, standard deviation. So, standard deviation is going to be the best measure of spread for our type of data. Then we need to calculate the value. They will tell you on this page here, if you keep scrolling down, here's the standard deviation. Essentially, the standard deviation is going to tell us for data that has a normal distribution, which is our data, 68% of the data will lie within one standard deviation of the mean. So here's how to calculate the standard deviation by hand, but we can also use Excel to do this. So first we want to calculate the mean of our data, which we did already. All right, next, let's click a box where we want a standard deviation to be placed. Click Insert Function, search to find standard deviation, STDEV, that option. Click it. Don't click any of the other ones, STDEV. Then you're going to select your data. Make sure you're not including the skew or mean or median in this, just the raw data. Push OK, and that will give us our standard deviation. Notice that for this and our skew, it's putting it out to a precision that is way too much. We don't need that many decimal places. So you can change this by going to Format Cell, if you right-click the cell, and then going to Number, Decimal Places 2, push OK, and it should round it to 2 decimal places, in this case the hundredths place. And you actually want to do that with your data because they will mark you off for that if you have different levels of precision throughout. All right, I believe that's almost it, right? Fill in our standard deviation there, and then you have. All right, and then this last step is to graph the central tendency and spread. Now this part is going to be really tricky. I don't know the best way to do this without me being there, and I don't have something that I can draw with on my screen. So you're essentially going to make these two things on this piece of graph paper that is in the lower left-hand side of your 11 by 17 poster. So one of the bars is going to look like this, which is what we call a box and whisker. It's going to be your median and interquartile range. And then the other bar next to it is going to look like this, which is like a bar graph, where the top of the bar is going to be your mean and then your standard deviation. So I'm going to start with this one, with my giraffe data, because I think it's easiest. So with my giraffe data, the top of the bar is the mean, which would be 4.89. And then my standard deviation is plus or minus 0.05. So on here, I'm going to scale this. Actually, you don't even need to do that. Yeah, actually, no, you do need to scale it out. So maybe, depending on what your data is, scale it out so that your mean is somewhere in the middle. My mean was 4.89, and so I'm going to have my bar. I'm going to draw my bar up to here, and I'm going to label this 4.89, which is my mean. Then I'm going to draw the standard deviation error bars, one standard deviation above the mean and one standard deviation below the mean. My standard deviation was 0.05. So I'm going to go 4.89 minus 0.05, which is 4.84. I'm going to draw my little box down to there, and then 0.05 above, 4.94. And so on my bar graph, I wish I could draw this, but it would be 4.89 at the top, and then I'd have my error bar, 4.94, 4.84. Now for the box and whisker, it's a little bit different. You're starting with your median. You want this to be in line with your bar graph on the right. So you want to use the same scale on the y-axis. For this one, figure out what your median is. My median was the same as my mean and mode, which was easy, 4.89. So my median is actually going to be at the same spot as the top of my bar graph. Then, whatever your maximum value is where the top of the box whisker goes. My maximum value was 5. And then whatever your minimum value is where the bottom of the box whisker goes. My minimum value was 4.76. So if this was my median, the maximum box whisker would go up to 5. The minimum box whisker would go down to 4.76. Do your best with this. Do it in pencil. I am assuming that you're going to need some help with this, and when I get back, I can do that. Remember, none of this is on the quiz Monday. I am going to have you turn these things in on Friday after the end of the day, or at the end of the period, because I want to see what you've completed. But again, you're going to have a chance to revise before I give you a grade on it. All right? I know this is a lot. I know it's hard. I had to learn all this stuff again when I was learning how to do IB biology, and I remember how difficult it was for me. So it just takes some time and practice, and don't hesitate to email me if you have any questions. Okay, remember, you're going to find your species by looking at the link on the assignment. Good luck.